You're standing on a beach 10,000 years ago. No tools, no fire, yet just sand stretching in every direction. Someone, let's not ask who, this is your problem now, tells you your mission is to capture sunlight itself and turn it into electricity. Not warmth, not a magnifying glass trick, actual electricity flowing through a wire. You look down at the sand under your bare feet and you genuinely laugh out loud. This stuff can't conduct anything. It can't power anything. It's just sand. And yet somehow, this exact pile of sand is about to become the single most important material in the entire clean energy industry. You just have a few thousand years of work ahead of you first. Step 1, and yes, you can already guess this part, don't die. You can't purify silicon to 9 decimal places of accuracy while also starving to death. So you do what every great invention in history required first. You find food, you find water, you learn fire, and you survive long enough to stop just surviving. Weeks pass. Then, for the first time, you have something no one in your position has ever had: free time. And free time is the only raw material that's ever mattered more than sand. Now, you can finally look at the ground with curiosity instead of desperation. And it turns out, not all sand is equal. Most of what's under your feet is contaminated with iron and other junk metals, completely useless for what you're chasing. You need a very specific, almost boring-looking white sand made of silicon and oxygen, called silica. You search, you sift, and eventually you find a clean deposit of it. It looks like nothing. That's exactly the point. Here's where it stops being ancient and starts being insane. You build a furnace, not a campfire, a serious furnace, one that climbs past 2,000 degrees Celsius, hotter than molten steel. At that temperature, with the right ingredients added, the oxygen gets ripped clean out of the sand. What's left isn't sand anymore. It's something called metallurgical-grade silicon, roughly 99% pure. You did it. You should feel proud. You should not feel proud yet. 99% pure is, shockingly, still garbage for what you need. You have to push past 99%, past 99.9%, past 99.99%, all the way to 99.9999999% pure, 9 nines, one impurity for every billion atoms of silicon. To get anywhere near that number, you'd eventually need to invent an entire chemical purification system, turning the silicon into a gas, distilling it again and again, then converting it back to solid form, each pass stripping away anything that doesn't belong. You started with beach sand. You're ending up with one of the purest materials a human being has ever managed to create. But pure silicon dust still won't do anything useful sitting in a pile. You need it organized into one continuous, unbroken crystal, because electricity hates moving through chaos. So you melt your purified silicon down and very slowly, just millimeters per hour, pull a small seed crystal upward out of the molten silicon while spinning it. Done patiently enough, you end up with a massive cylindrical crystal, sometimes taller than a person, perfectly uniform from top to bottom. You just grew a crystal out of melted sand using nothing but heat, rotation, and absurd amounts of patience. That crystal gets sliced into wafers so thin, they're roughly the thickness of 2 human hairs. Each wafer becomes the foundation of one solar cell. Close, but a flat wafer of pure silicon still produces nothing on its own. It needs one final trick, and this is the cleverest part of the entire journey. You introduce tiny, deliberate amounts of other elements into the silicon, phosphorus on one side, boron on the other. This is called doping, and it isn't cheating, it's the whole secret. Phosphorus gives one layer extra electrons. Boron leaves the other layer short of electrons, creating gaps scientists call holes. Now you have 2 layers sitting side by side, one overflowing with electrons, one desperately short, both wanting to balance out but unable to do it alone. You've just built an invisible imbalance. That imbalance is the entire engine. Here's the payoff you've been chasing this whole time. When sunlight strikes this wafer, the energy physically knocks electrons loose from their atoms. Those freed electrons, sitting right at the boundary between your two unbalanced layers, suddenly have somewhere to go. They rush from the electron-rich side toward the electron-poor side, and if you give them a wire to travel through, that movement of electrons is electricity. Real, usable, powers a light bulb, electricity generated by sunlight hitting a slice of what used to be beach sand under your bare feet. You add a thin coating, so the cell absorbs light instead of bouncing it away. Press tiny silver-colored metal lines onto the surface to collect the current, and seal the whole thing under a sheet of tempered glass to survive decades of rain and sun. Wire several cells together, frame them in aluminum, and you have one finished panel. You mount it. You wait for morning. The sun rises. Electrons start moving across that invisible boundary you built. The panel begins producing power from nothing but sand, heat, and an idea that shouldn't have worked. Most people think solar panels are a futuristic invention dreamed up overnight in some lab. They're not. Their sand survived first, then purified to a level that sounds like a typo, grown into a crystal, sliced thinner than a hair, deliberately unbalanced on a microscopic level, and finally handed sunlight as the last ingredient. Every solar farm stretching across a desert, every panel bolted to a rooftop, started exactly where you're standing right now. Bare feet, ordinary sand, no idea what was hiding inside it. You came here with nothing but dirt under your feet. You're leaving with sunlight turned into electricity.